In this example, we're going to go ahead and take a look at the independent samples t-test. And in this example, assume we have two study methods here, which I refer to as study method A and study method B. And in this example, assume that we have these two study methods and we're trying to see whether one or the other is more effective on test performance. So do people who take study method A or people who take study method B, do either of them do better in terms of test performance? Or is there no difference between the two methods? Okay, and here for study method A, we have the sums of squares for study method A of 160. There are 10 people who received this method, and their mean after taking the test was 65. For study method B, the sums of squares was 200. There were also 10 people who took this method, and their mean was 59. So we want to conduct a hypothesis test to see if there's a significant difference between these two groups on test performance. So we'll go ahead and start by stating our null and alternative hypotheses. So here the null would be the mu, or population mean, for study method A is equal to the mu, or population mean, for study method B. The alternative hypothesis would be that the two study method population means are not equal. And the reason why I'm doing this is a two-tailed test, and the reason why I'm conducting a two-tailed test is because I want to see whether A is significantly higher than B or B is significantly higher than A. Either outcome would be possible this way with a two-tailed test. Okay, next we're going to go ahead and find our critical value for the test. And here we'll use alpha 0.05, and we're going to use once again a two-tailed test. And in order to do this, what we need to do is to look up the degrees of freedom in the t-table. Okay, and here I'm just going to show you how to find the degrees of freedom and then give you the actual critical value, and you can confirm that on your own. So the degrees of freedom is equal to n1 plus n2 minus 2, or n1 minus 1 plus n2 minus 1. Either way or method is acceptable. Okay, we'll do this first one here. So we have, notice for n1 and n2, we have 10 people in the first group and 10 people in the second group. So our degrees of freedom are 10 plus 10 minus 2, or a DF of 28. Okay, and if you look that up in the back of your text, you will find a critical value for a DF of 28 with alpha 0.05 is equal to plus or minus 2.101. Okay, in part 2 of this video lecture, we'll go ahead and calculate the t, and then we'll compare it to this critical value and make a decision about the null hypothesis, whether this null hypothesis should be rejected or not. Okay, so please join me for part 2 in this lecture.